Let's talk about some chemicals, how we can control microbial growth in our environment with chemicals. And that's what we do a lot of. We like to spray stuff and do chemicals to control microbial growth. Okay, I ended the last video with a chart of physical methods. This is from your book, and this is the next chart that talks about chemical methods. So it's got all the different types of methods, how it acts. I definitely want you to look at this level of activity. And in fact, I didn't organize it quite the same way as the book. I'm actually looking at working our way through levels of activity as we work through the chemicals. And I definitely want you to look at how you use these and what's the best choices, because that's what test questions are going to be about, and that's what real life is going to be about. You have a chemical, you have a situation, you need to know how to control microbial growth. What's the best thing to do in that situation? That's real life. So that's what I want you to focus on. All right, so I said I organized this a little differently. I'm going to start with level of activity, and if you remember, we talked about that, like how clean do you need it? If we're talking about our skin, you know, something that we're using on the outside, we just need it regular clean. We don't have to get rid of all pathogens. Just reduce the number enough that when a typical person comes in contact with it, we should be able to fight them off. That's what I'm talking about when I mean a low level of disinfection. So how can we achieve a low level of disinfection with chemicals for that? So let's talk about that first. Okay, the first thing I want to address about this is a product called surfactants, or a category called surfactants. Surfactants is short for surface active ingredients. Again, this is a low level disinfection. We're just trying to get rid of a good number of pathogens, things that are going to come in contact with it. We still have our skin that are going to come in contact and protect us. All soaps and detergents fall into this category of surfactants. Soaps and detergents are different. Soaps work on our skin. They are made of chemicals that have hydrophilic and hydrophobic ends. Detergents work on a positive charge. Let me talk about soaps first. Here's our soaps. Hey, with lectures in my kitchen cable, you guys get lots of props from my kitchen. So this one is my soap. This is still left over from Easter, so there's my little bunny on my soap from there. Evidently, we need to use more soap because it's still pretty full. But a soap is a surfactant. I'm going to use that on my skin. A soap is going to be made up of a chemical that has hydrophilic and hydrophobic areas. I'm going to kind of draw them in ways that, remember, it's not a phospholipid membrane per se, but the chemical structure has hydrophilic and hydrophobic regions. So hydrophobic regions are not soluble in water. Hydrophilic are going to be soluble in water. And what happens with that soap is that and when we mix soap and water, my hydrophilic areas are going to be where the water is. My hydrophobic areas of this chemical structure are going to be away from the water. And just like a phospholipid bilayer, it ends up, these hydrophobic areas end up all coming together, trying to get away from the water. So my hydrophobic areas of the soap come together, and they form these kind of circles that they call micelles. I'll write that one out. All right, so that's what happens with soaps. They make this. Now you're going to put this in your hand and you're going to scrub. And when you do that, when you start scrubbing, what happens is you're going to lift up the oils from your hands as you're scrubbing with your soap and your water. And so my oils get lifted up. My oils are not soluble in water. My oils are going to be hanging out with the hydrophobic regions, and they get lifted off of my hands into these micelles and away from my hands. So the oils get lifted, and the thing about it is not only the oils are getting lifted, but what's attached to the oils are going to be microorganisms. So the bacteria, anything that's on your hands will get lifted up. Dirt as well, gets rid of dirt as well, and it gets formed into these little micelles. You scrub them so the oil gets lifted, gets formed into these little micelles, and then you rinse them off. This is a physical way to remove bacteria, to control microbial growth from your skin, from that. So this is how soaps work. It's a surface active. It's not killing anything. The bacteria are still alive and well in here, but when we rinse them down in the drain, they're not a problem for us anymore. So it gets the job done. All right, so that's how soaps work. Detergents actually work different. Again, from my kitchen cabinet, detergents actually work different. All right, that's my dog. Gotta let my dog out. Detergents work on charge, positive, negative charge. We use detergents on surfaces like dishes. We use detergents in our clothing. They don't work this way. They actually work by a positive, negative charge. Bacteria typically have a negative charge to it. This has a positive charge. They'll stick to it and remove bacteria from our garments and from our dishes that way. All of these are a low level. All of these are surface active. There's no killing involved. It's just a removal, a physical remover. So when we're talking about degerming, we learned that word, and the scrubbing of your hands, that is just as important as the soap. So scrubbing your hands and getting all of that is just as important as the soap. Now, one other thing with antimicrobials, a few years ago, we had a lot of antimicrobial soaps. If you've noticed, you can't really find those in the store anymore, in case you've been looking for this. Antimicrobials are a soap that had antimicrobials actually had a chemical in it that actually kill bacteria. So not only were you working with the soap and those micelles and physical removal of bacteria, but you actually had a chemical, an antimicrobial, some sort of chemical in there that would kill the bacteria. What we have found is that's overkill. We don't need it. The soap, just regular plain soap, works just as well as antimicrobial soaps. What we've also found is we've talked a lot about in this course about superbugs, these bacteria that are becoming more and more resistant. Every time we throw antibiotics at these bacteria, we kill off the ones that are susceptible, and the ones that are resistant are left behind, and they replicate and grow. So every time we add antimicrobials to our environment, we're setting up the right circumstances to leave the most resistant ones behind. So because of that, antimicrobial soaps, they've limited those to hospitals, healthcare settings. They don't sell them for personal use anymore, and that's a good thing. The more we know, the better choices we can make from that. Okay, so those are your surfactants, surface active, your soaps and detergents. This is a low level of that. Another thing we use a lot in this low level area is called quaternary ammonium compounds. These are great. It is a chemical that we use, so we're actually killing stuff. It actually disrupts some cell membranes, can get rid of bacteria, viruses, fungus. But the good news is that they are odorless, tasteless. There's no side effects. So we can use these a lot without harming ourselves. Again, we're just getting rid of a low level. We're getting rid of a lot of things, but we don't have to get rid of everything. And the harsher the chemical we use, the more likely they're going to cause damage to our cell membranes and our DNA, and we don't want to do that. So quaternary ammonium compounds are in a lot of products. It's just an overall good disinfectant, low-level disinfectant. Where do you find it? In your mouthwashes. You can see them there. Hand wipes. And I, again, have my handy-dandy things like this. I was able to get this before all the stores ran out, but these Lysol wipes. Lysol, you think they actually have Lysol in them. Lysol, we're going to look about that. It's a pretty harsh chemical. It's a phenol. It's like carbolic acid. Was the original Lysol, but Lysol is a name brand, and it produces a lot of types of disinfectants. This one, if you actually look at the ingredients, it's a quaternary ammonium compound. It's a quat. It's these wipes that we use to disinfect surfaces. It's a low-level disinfectant, very few odorless, tasteless. It's easy to get rid of a lot of things. So these are ammonium compounds. So be careful. Your Clorox wipes, same thing. There's no bleach in your Clorox wipes. They're probably that quats, that quaternary ammonium compound. So definitely watch what you're doing. Look and see what you're using. This, again, is low level, gets rid of a lot of things, no side effects, and it can make a difference. So that is something else that can be used as a low level way to control microbial growth. Now, it won't get rid of everything, and there's actually a few bacteria, this is one in particular, that can grow just fine in these quaternary ammonium compounds and these quats. So it doesn't get rid of everything, but that's okay. We've still got skin, we've still got physical barriers. We're not trying to get rid of everything. We're just trying to reduce the number of pathogens. All right, so that is another type of low-level way to control microbial growth with chemicals. Let me do another one. Brass. Let's talk about some metals. There is a tradition in some areas where they always gather water in these brass containers. So villages, towns in India, places in India where they actually need to go to the communal river to gather drinking water, the people that would do that, instead of using a plastic or a ceramic type pot, they would gather it in these brass pots. And the reason they did that is because they said that it prevents disease. So scientists came in, wanted to test that and see if that was true. And so they took bacterial river samples, and they counted the bacteria in there. And again, this is a river, goes through the community. We've got boats, we've got washing, we've got everything in there, and they still don't. They're shared. With all activities, including drinking, bathing, cooking, everything comes from the one main river. And so when they did river samples, they found fecal bacteria, so contaminated with sewage, fecal bacterial counts as high as 1 million bacteria per 1 mil of water. Now that's a lot. Hopefully you're cringing as you're hearing that, because it really is a lot. 1 million of bacteria per 1 mil of water is a lot. So they took They took river samples immediately, and then they did it after 24 hours and after 48 hours of sitting in these brass pitchers. And what they found was that bacterial fecal counts started out at 1 million per mil and dropped to near zero after 48 hours of sitting in this brass pitcher. They did not see the same thing in plastic or earthenware containers, so it didn't have to do with sunlight or anything like that. There was something to do with this brass. So the people who lived there were correct. Gathering water in these brass pitchers did prevent disease. They prevented that fecal to oral contamination, sewage and fecal matter, and then consuming it by the next person and causing a disease. So they were correct. All right, so why were they correct? What is going on with this? The reason it's correct is that heavy metals actually have a low level of bactericidal properties, bacteriostatic, fungistatic properties. So the heavy metal ions, and this brass is made out of brass and copper, or copper and zinc, and this brass pots coming into contact with the water and with these pathogens would denature the proteins in these bacteria. So they denature the proteins, they get rid of them, they can't grow, and then they're going to prevent disease. So this is a natural disinfectant agent and way we can control microbial growth. We do this in our rivers here. Rivers, I say that loosely. Anybody live in a neighborhood that has those ponds at the front and they have some kind of abnormal blue color to them? They're not natural. I mean, they're natural, but they've got a different color to them. We will treat the ponds that we don't want to have natural, and meaning algae grows, lots of different things grow. We'll treat those with copper to control that. So we do that here at Lone Star. That's the River of Knowledge. That's what we call that river running through campus. You do it in your neighborhoods. Again, you're treating it. It's a low level. It's safe for the fish, for the frogs, for that, so it doesn't build up. Again, it's a low level disinfectant. But it does control these algae growths that can bother us. All right, so we use it there. Where else do we use heavy metals? We used to use a eye drop with silver nitrate in it. We used it on newborns, and nowadays we still use these drops on newborns, but they're made of a different type of bactericide or antibacterial cream at the moment. But we would find that if babies were born to mothers who were infected with gonorrhea, they would go blind. They would pick up that gonorrhea as they passed through the birth canal, and they would go blind. And so they could treat that by using the silver nitrate drops in the newborn's eyes, and it would get rid of anything that was picked up during the birth. So we still do that to protect our babies. We don't use silver nitrate anymore. We've got some better types of antimicrobials, but they'll ask you after the delivery, do you want the antibiotic cream in the eyes? And again, that's a way to easily prevent blindness. Before that, that was the leading cause of blindness in newborns, was contamination with pathogens after birth. All right, all of those are heavy metals. All of those are a low-level means of controlling microbial growth. All right, what else is in this category? All right, that's it for low levels. So again, the big thing to remember from that is these are surface active. These are zero or very few side effects. They're very safe, and they will control microbial growth when there are other methods of protection, meaning your skin, your mucous membranes, that kind of thing. Okay, I'm going to stop that video here, and we will pick up the next one with the intermediate level of activity. What chemicals will work control microbial growth? These are going to be stronger, but they are going to do a better job with that. Okay, all right, so thank you. Keep going. I'll see you in the next video.